Hello. Today I'm going to go through how you fill out the new budget sharing form that Bechtel has. So we are now giving out some amount of our Kennemetal budget to teams who are using the center a lot and would like to request some tools. The main thing is how to make the Fusion 360 tool library. We ask three things. We ask for acknowledgement that the Bechtel Center is a sponsor of the team, some form of media for the center, and then a Fusion 360 library for all tools that you request, even if you don't receive them. This is because if we see that you guys are using a tool very well, or we are wanting to purchase that tool for the center, we want to have the tool library all rebuilt and how you guys ran it, just because that saves some tool testing for us. So I'll just go through how to make a new tool in Fusion 360. I'm going to do this in my own folder for now. I'll just go into library and create a tool. The tool that I'd like to show you how to make is our Harvey 2TE. This is a new tool, and we're currently getting it for the center. So we will first go to Kennemetal Novo, and then you'll sign in or create an account, and you'll get to this page. And then you can search for the tool you want, so Harvey 2TE. All right, so Harvey 2TE, and then we're going to go for a 1/2 inch Harvey 2TE. Here we go, and then we will select which one we want. Let's just go with the first one that's here. It doesn't actually matter which tool we use, and then let's choose this one. So this is a tool that I want to get, and I now need to put this into Fusion. There's a couple pieces of information that we need to care about at first. That's one, this order number, and two, the catalog number. Behind the scenes, Kennemetal calls this their ANSI number, this H2TES E0, that number, that's their ANSI number, and then the 7-digit code is their SAP number. ANSI numbers are not unique. You can have two different tools with the same ANSI number, but these SAP numbers are unique, and that's like their SKU. So so this is a flat end mill, so I will click on flat end mill, and then the description will be Harvey 2TE, and I'll add a 1/2 inch. Harvey 2TE, the vendor is Kennemetal. We will not be purchasing non-Kennemetal tools because we're sharing our Kennemetal budget that they've sponsored for us. And then this product ID is another important thing. So we have how it works is we have a category name, colon, the SAP or ANSI number. So we can just make up our category name. So Harvey 2TE can be our category name, and then we'll put in the SAP number. And then I'll add a comma, and then I'll do the same category name, but I'll give it the ANSI code as well. And this is just in case someone is wanting to read the ANSI code and know which tool they have. The ANSI code will tell you some information about the tool, and you can look at Kennemetal's catalogs to see how you get that information. So this is basically how it works. We have our category name, our SAP number, and then for the ANSI, we have the category name _ ANSI and the ANSI number. All right, now we can grab the link to this. I'll just click on it, copy the link, and throw it in there. That's not necessary, but now we can start creating this tool itself. So this is clockwise. The number of tools is, we have number of effective flutes is 5, so the number of flutes is 5. This is a carbide tool, not ceramics, carbide, and the diameter is 1/2 inch. The overall length of the tool, if we go here, that's L is 4, so I'll say this is 4. Length below holder, we're going to say that's a little bit past the max flute length, but when you actually get this tool in hand and put it inside a holder, I want you guys to note at what length you're putting this down, what is the standard length, and change the value inside the Fusion library. All right, so AP1 max is going to be our flute length, and I'll also change the shoulder length to be the flute length, and then we'll just say this is 1.875 for the length of the holder. Again, you'll need to verify this and make sure that this is correct. This page looks good. For shaft, in this case, we don't have to do anything. And then under holder, since this is a carbide tool, this will go into one of our Hydroforce holders. As you can see in our tool holders, we have two different Hydroforce holders, one with this sleeve here, and then one without the sleeve. Since this is not a 3/4 inch shank tool, we need the sleeve. And then under cutting data, this is where it's going to get fairly tedious. You need to import all the feeds and speeds that Novo tells you. All right. I'll click on that feeds and speeds button, and then we can see that it has a bunch of cutting parameters as well as some information here. We'll first start by naming it, so P0 dash, and then this is low carbon steels, long chipping. And I just copy this, and then I will edit this again and paste that in there. All right. At the center, we have a couple of rules. So our axial depth of cut, we want to be 90% of the flute length. So I'll just go 1.625 times 0.09, and then, sorry, times 0.9, 1.625 times 0.9. All right, and then that will be our depth of cut, and then our radial width of cut is going to be 10% of the tool diameter, so that's 50 thou. And then for now, we're just going to leave the defaults alone and see what this gives us. So this is saying we're going to be spinning at 4,300 RPM and moving at 22 thou per rev. That seems fine for me because, like, while this is quite fast, I think this tool can take it. But the main things we need to check are the power and torque at tool. We need to make sure we're not exceeding our machine spindle limits and going above 100% spindle load. To see where that comes up, we can look up Haas torque curve. And then we'll see this torque chart here. We'll click on that. And we'll see we have a bunch of charts for different machines. So this is our, at the top, this gives us our VF, VM, and UMC series, and this is a 20,000 RPM with a 40 taper spindle. So this thing here would be our UMC 500 spindle, and right now I'm making a tool for the VF2, VF, and VF4s, so I'm going to use this torque chart here. So this is the 15,000 RPM, and it's 40 taper as well. All right, this first chart here is our inch, the inch version, and the bottom one is the metric version. So since we're using inches and foot-pounds, we're going to use this first chart. Another thing to note is values are shown at 200% spindle load. So all of these values you need to divide by 2. It's a little bit misleading, but at 3,000 RPM, we don't actually have around 80 foot-pounds of torque. We have 40 foot-pounds of torque. So we said that this is spinning at 4,300-ish RPM, so that's somewhere over here. So we have around, let's be conservative and say 30 foot-pounds of torque and 40 horsepower. All right, so, or sorry, not 40 horsepower, 22 horsepower. Yeah, 22 seems right. So we can go over here and make sure that our values are within those range. And yes, this is less than 40 and this is less than 22. So I think this is fine. Again, when you actually go and run this tool, whatever you adjust your feeds and speeds to be in the range in the material cutting is what we would like you to adjust your feeds and speeds in the Fusion library to. All right, so I'll enter all of this. So this is going at, our cutting speed is this thing here. So I'll change our surface speed to that. And then our feed per tooth is 4 thou. Seems a little bit fast, but it's fine. Our ramp feed rate will be tool underscore feed cutting divided by 3. And that's the same thing for our plunge. If this goes below like 5 inches per minute, you can change it to be a little bit faster, but we'd like these to be standard for now. And then we'll check the U step down and U step over. So the step down is going to be this number here, and then the step over is going to be, again, be 50 thou. All right, so that's one value in the feeds and speeds. Now, if we go here, we can see all of our feeds and speeds that we're going to need to put in. We're going to need to do this process for every single one of these materials and in the slotting configuration. So depending on the tool you have, that's going to be a lot of feeds and speeds, and it's going to take you some time, but it's what we'd like to see in order to give you guys this tool. All right, let's say you've done all of that. The final thing you need to do is change this number here to 0. That means this tool won't be reserved in a tool slot, and it'll be nice. It'll work nice, and it'll play nice with all of our other tools. All right, there are a lot more complicated tools. So if we go and look at our extended tools, so let's say extended square end, and let's edit this, and then I can zoom in here. You can see that this tool, sorry, that's rotating. I want it to pan. This tool has a larger diameter here, a smaller diameter here, and then goes back large again. The way that you do this is you're going to set your diameter to be whatever, and shaft diameter to be whatever is going, the shaft diameter is whatever's inside the tool holder, and your diameter is whatever the cutting diameter is. And then under shaft, you can then go and specify, hey, I actually have this diameter here in this portion of the tool. It's not highlighting for some reason. It usually does, but this is this portion, this necked portion here, and then this is at the top, and this is just all the way in the tool holder. Another thing is if you request a tool holder, you're going to need to make the tool holder model. I'm not going to show you how to do that today. NYC CNC, they've created a great script for doing this, and they have this page here that I'll have in the description. But overall, we just need to make sure that all of your tools have feeds and speeds, all of your tools are how they are going to be in real life, and then you can export your tool library with just a single tool in it as a JSON. So if I right-click this library, I can say export library. I can name this whatever I want and make sure this is the .json form, and then submit this as a file inside the form. So that goes into here. And then you can submit the form and we'll get back to you whether we're buying your tool or not. Thank you.